we were getting.
I know, it just changed, you know,
Oh,
like, Jen was like, "Ooh, what's going on?" And then just kind of like,
Okay.
are we done?
Did you get this, Trey? Did you get this?
I got it.
Okay. Oh, this is gonna be fun. So we don't even need a graph, we just need to describe the transformation. That's not too shabby. So the base is the same. That's good news. Okay, so if I just start it, so I see f of x is positive, g of x is negative. So what is this negative symbol doing? What kind of transformation does that create?
Oh, it's going down.
Yeah. So if I was using like transformation words, I would say it's a reflection over the x-axis. Yeah. Because I was below the x-axis, it's above, so I'm going to say reflection. I didn't use those words when I said before, but this is like formal wording. Okay, what is this negative in the exponent do? Yeah, so instead of exponential growth, I have exponential decay. So if I was using an actual transformation, we'd say it's reflection over the y-axis. Okay. So here's the weird part. So basically this negative x plus x, I can factor out that negative 1 piece, so I can write the horizontal shift correctly. So this can be written as negative x minus 6. So the minus 6 is indicating which direction. Yeah, so it's going right 6. Because the horizontal shift at h value is always the opposite sign. So these are my 3 transformations from f of x to g of x without graphing it. Good with that? Okay. So let's actually graph one and see how this works. Okay, so the first thing I would do is figure out what is the vertical asymptote. That's if it's irrational. So now we're going to exponential, so it's different. Vertical asymptote we said was the k value. So do I have a k? Negative 1 is the k value. So my vertical asymptote, oh my gosh, I meant horizontal. Was that what you're thinking? Okay. I meant horizontal asymptote, so I can take one. Okay. So you can graph the asymptote. Is my exponential going to be above this asymptote or below it? Above because my a value is positive, So it should be above. There's horizontal axis. I guess if I was doing this, I would just make a table and plot the points. And since there's no horizontal shift, I would just do -1, 0, and 1. Then play plug-in equals 1, 2. So if I did -1, what is 1/2 to the negative first power? 2. If you flip it, so 2 times 2 minus 1 is 3. -1, 3. If I plug in 0, what would I get out? What? Yeah, because it should be 2 times 1 minus 1. And then I'm plugging in 1, 0. Okay. And going and approaching my asymptote. So this was decay because my p value was 1/2, so it was less than 1. So that should be decaying. The 2 basically just like vertically stretches your points a little further away. Which typically are. So that's graphing. This is the greatest property ever. Just to let you know. So it says if a to the x equals a to the y, then x equals y. So basically, if you have an exponential equation you want to solve, you want to try and create the same base on both sides. So that way you can just set the exponents equal to each other. So once you have the same base, they can kind of just like cancel out, and you solve the exponential equation. That's the goal. We'll do the one-to-one property quite often as well. So I have 16 equals 2 to the x plus 2 power. So on the left side and the right side, I would like to have the same base. So on the right side, I have a base of 2. So I would like to rewrite 16, so that way it has a base of 2. So if I was doing it, I'd have 2 to like what power is 16? 4. So I can rewrite 16 as 2 to the 4th, and I have it equal to 2 to the x plus 2. So since I have the same base, I can use the one-to-one property, and I have x 4 equals x minus 2, or x plus 2. Solving for x equals 2. Nice. Okay, last one, I believe. Okay. So this one is kind of interesting. I have 1/3 as the base on the left side and 81 on the right side. Anybody have any ideas? How could I rewrite 81 as an exponential expression? Okay, so 81 is equal to 9 squared. How else could I write 81? Yeah, that's all. So equal to 3 to the 4th. So I'd probably use 3 to the 4th because that's closer to like a third. Okay. So once you have this, still can't use one-to-one property because they're not identical to each other. But maybe on the left side, could I rewrite a third? So it's 3 to a power. Yeah, I can write 1/3 as 3 to the negative first. So 3 to the negative first, so the x equals 3 to the 4th power. So then I can set my exponents equal to each other. the negative 1 and the x power, they're basically multiplying, so negative 1x equals 4. So x equals negative 4. I like this. I think they're nice. Lovely. Tomorrow we're going to do more interest stuff. Then we have a quiz on Friday. So exciting. Did you guys watch the Veterans Day video? Sad. It was pretty good.
Was it actually pretty good?
I liked the first part when the lady was talking about her son. And it was like the poster that Molly has in her room of the army guy. It was about him. I thought that was interesting. And there was a lot of pictures and stuff later, but the first part I would watch.